Welcome to Unimus NMS Sync feature showcase video, where we present the most important aspects of sync logic rework. In the following 7 minutes, you'll gain the know-how on device import from NMS to Unimus. To begin, let's look at the environment we will be working in. We have our Unimus server with 2 manually created devices, a router in Zone 1 and a switch in the default zone. We'll be using FQDNs instead of IP addresses for better clarity. On the NMS Zabbix 5.4, we have 3 devices we want to sync into Unimus. They all have their host names configured in the DNS name value on the interfaces. Note that the actual host name values are imported as device descriptions. It is how the Zabbix NMS connector is implemented in Unimus. That's our status quo. Let's move on to creating an NMS Sync preset for our Zabbix instance. We'll select the NMS type and fill in the connection details. And we will change the address field priority to DNS over IP, since we want to use the FQDNs instead of IP addresses. For Zabbix Sync rule identifier, we can specify host groups, templates, or tags. Since we have our Zabbix devices tagged already, we'll use tags as identifiers. Add tag A, prefixed by the @ sign, and select Zone 1 to sync into. Hit Run Sync and we get our UI Sync notification of a successful job. Let's check the Devices tab. We should have devices Rowdy and newly imported device Switchy now synced by Zabbix preset. Good stuff. Looking at import log confirms what happened during the sync. A user ran the Zabbix Sync preset, 2 devices were provided by Zabbix, and 2 local devices were processed. 1 was imported, that's Switchy, and 1 was updated, that was Rowdy, with the description change. Next, let's try to adopt Steve by our Zabbix Sync preset. It is currently not adopted by any preset as it was added to Unimus manually. On Zabbix, Steve has tag B assigned. If you remember, Steve is currently located in the default zone. It is outside this sync's preset zones because only Zone 1 belongs to this scope. This is why we need to change the device action policy to move from all zones. This tells the sync logic to try to find and adopt a device, matching one being imported from Zabbix in all Unimus zones, before attempting to add a new one. Now we can create a new sync rule to get devices with tag B and sync them into Zone 1. Hit Save and Run Sync now. We can glance from the notification that one device has been updated. Checking on the devices, we can already see that Steve has its description updated and was also moved to Zone 1. Looking closer, we see it is now adopted by our Zabbix preset. Inspecting the import log confirms that 3 devices were processed. 2 had no change done on them. 1 had its zone and description changed. Next, we'll have a look at how Unimus handles device changes on the NMS. We will remove the tag from Rowdy so it is no longer among devices provided by Zabbix during NMS Sync. Then we simply save and run the sync, and the results are in. 1 count of newly orphaned devices and a same count of 1 for all orphans, no action. What this means is that 1 local device, Rowdy, has been orphaned as a result of not being among devices provided by Zabbix during the sync. Checking closer, we can see that Rowdy is now orphaned with orphaning reason saying, device not present on NMS. Moving on, let's explore what Unimus can do with orphaned devices upon completion of NMS Sync job. We'll just change Switchy's tag so it gets orphaned upon the next sync. Head back to the preset configuration and change the orphaning policy from no action to unmanage. Hit Save and Run Sync. Bam! 1 newly orphaned device and a sum total of 2 for all orphans. Unmanaged. Checking on the Device tab, we can see Rowdy and Switchy in cursives now, meaning they are no longer managed by Unimus. Next, we will introduce another different NMS type into the environment and see this new NMS preset's interaction with the existing orphaned devices. We have Libre NMS set up with device group Libre Group 1. Rowdy and Steve are its members. The NMS preset is already prepared. The one sync rule set up here specifies devices in Libre Group 1 to be synced to the default zone. We'll just change the device action policy to move from all zones with the intention of adopting eligible devices from all Unimus. In our case, the eligible devices are those orphaned under Zabbix preset, currently residing in Zone 1. Save it and run the sync. Notification reveals an import and an update. Let's look at our devices. Right off the bat, we see Steve twice. This is the expected behavior. A new device was imported from Libre NMS. Existing Zabbix Steve was not adopted by Libre NMS as this device was synced and adopted by Zabbix preset already. Devices synced by other presets are off limits. Just imagine the chaos and cross-preset device mishandling that would ensue. It's a completely different story for Rowdy. This one was orphaned before the sync, and so it got adopted by the Libre NMS preset. Finally, we'll mention UUIDs. They stand for Universally Unique Identifiers. Some of NMS types supported by Unimus, namely Libre NMS, NetXMS, Observium, and Panopta, provide them during a sync in addition to device addresses. They augment the information used in the identification of devices for a more consistent device tracking between Unimus and the NMS. Okay, let's learn by doing. First, we'll get rid of the duplicate Steve that was just created. Sorry, Steve, but you were a mistake. Next, let's switch to the Zabbix preset configuration and delete the second rule. This happens to be another action that causes orphaning. Checking in Zabbix Steve's device info, we can see it is now orphaned. The orphaning reason: sync rule deletion. As a note, two other actions cause device orphaning. One is changing the rule zone in a preset, and the other is manually moving a device between zones. With Steve orphaned, let's rerun the Libre NMS preset sync. As expected, Steve is now adopted by Libre NMS preset. To showcase the value of UUIDs, we're going to manually change Steve's FQDN to George. Run the Libre NMS sync again. Looking at the results, we see that Steve is back. This is because the device was identified by its UUID and updated to match the DNS name provided by Libre NMS during the sync. Likewise, address change of a device on an NMS supporting UUIDs would reflect on Unimus after running a sync, as the NMS is always the source of reference. Thank you for your patience. We trust this showcase has shed light on the powerful yet simple-to-use feature that is NMS Sync in Unimus. For more detailed documentation, be sure to visit our wiki. And in case of any questions or challenges encountered along the way, feel free to navigate to the support section on our forum. Happy syncing.